Linear algebra. Part 1. We do a first part of linear algebra that is actually just linear algebra. And then part 2 is going to be actually linear algebra for control systems. Okay, so now we are going to go through some generic stuff. You should already kind of know what I'm going to say in these, what we are going to say in those 2 weeks, first 2 weeks. But we give some more interpretations. Where are we? We did this part of the course. We talked about differential equations, about stabilities. We talked a little bit about nonlinear systems. And we saw how H and H, in a certain sense, are central to characterize linear time invariant systems. True? Now, with this linear algebra part, we are going to see that actually those representations are partial representations. They do not give everything. They give only input-output representations. This message is going to become very clear. Whenever you will restudy and rewatch the videos, at the end of the course, it has to be very clear how the linear algebra part that we are doing right now is to kind of give the intuition or to explain why this part that we did up to now gives only the input-output relationship and not the full picture. Okay? So we understood some stuff up to now, true? We arrived up to now. We should do like this with ourselves, that we are in a good place. We understood a lot of stuff. Now we improve even more. Okay? And indeed, why do we study linear algebra if we are doing control? So, very, very, very easy. If I have this object here, that is spring mass system, RCL circuit, whatever you want. So ARMA, simple system. We are going to see very soon how we are going to be able to rewrite everything in terms of a state space representation. Actually, I think we already did it. The going from ARMA to state space, we did it, true? I think we did it. So you've got to remember. And this one, that is second order single input, becomes first order single input, but vectorial, while this one was scalar. Okay? And this one, so let's make a try. If I have y dot is equal to minus 3y plus 2u, the free evolution starting from y0 equals to minus 5. Y free evolution of t is going to be equal to what? You do it. You shall have no doubts about this, okay? At the end of the course, at the exam, no doubts about this. The solutions are going to be exponentials, true? Exponentials that have to pass through the initial condition. Minus 5e minus 3t. Together, not at all, kind of. Where are we? Excellent. Guess what the solution is going to be. The solution is going to be, we are going to say it very soon, x free evolution of t is going to be EAT x0, where this object here is going to be what? A matrix. From a structural perspective, I hope you see that it's the same. This and this is the same, true? And the same with the convolution is going to be a similar thing. We will see how, whenever we consider the force response, we will get something that is essentially the same object, that is a convolution object, multidimensional. Okay? So, Why do we do linear algebra? This is going to be a matrix whose properties depend on the properties of this matrix here. Since starting from an ARMA, I can go to this one, and since the properties, algebraic properties of this will imply the evolution of the system will be characterized in a certain way, doing linear algebra is essential. Okay? So we will always have to deal with linear algebra in control. Okay? That's why we are going to do 3 blue, 1 brown. This one, you have to do it. Strang linear algebra in YouTube. Nice, a little bit longer. Okay? If you want, watch it. It's going to be longer and more focused on linear algebra and linear algebra. This one, there's a book in a Blackboard that I put. This appendix here is everything that you need to know from a control perspective about linear algebra, PhD level difficulty. Okay? Very formal, very mathematically precise, very not connected to reality in the sense that it's research-oriented stuff. Take a look. Okay. So, essentially, we are going to always deal with stuff like this. Properties of this will enter into your controller. Actually, you will design your controller depending on the properties of this stuff, analyze the properties of this and this, linear algebra. You have to know. How much are we together, people? Excellent.